So here is another question on the determination of equivalent resistance. Okay, so this is the circuit across which you have to find out the equivalent resistance across the points x and y. Okay, so the important thing to take notice here is this portion. Okay, this curve, okay, this one, it denotes that the two connections or these two wires, they are not shorted, they are not shorted together. Okay, this is very important. It means that these two connections, this crisscross connection, is not shorted. Now this circuit might first look a bit tricky because of these extended portions. So the first thing to do is to remove them. They are deliberately given to create confusion. Now see, this 300 ohm resistance and 500 ohm resistance have one common point. Okay, they have one common point, and this 500 ohm resistance has its other end connected to 300 ohm, this top 300 ohm resistance. Okay, so there is an end-to-end connection pattern of this 500 ohm, this 500 ohm and this 300 ohm resistance, while the common end connection means the left end of this 300 ohm resistance and the left end, let's say, of this 500 ohm resistance is connected at one common point. So it means that this 500 ohm resistance and this 300 ohm resistance are connected in series. It will get added up here. Now this 500 ohm and this 300 ohm has their left ends connected at one common end, this common point which is connected to x, while this 500 ohm resistance and this 300 ohm resistance, they have an end-to-end connection pattern. This 300 and this 500, they have an end-to-end connection pattern. It has its one end connected, the starting end connected to its tail end. So it means this 500 ohm and this 300 ohm are in series. Now let us simplify the circuit. This marker, okay. First we'll take this 300 ohm and it is in series with this 500 ohm. 300 ohm and this 500 ohm. Next we will take this 300 ohm, okay, this will proceed in this direction, this 300 ohm and which is in series with this 500 ohm, okay. First this 300 ohm and we'll move towards this 500 ohm, and this 500 ohm resistance has its other end connected to this 300 ohm, the common point, okay. So 300 ohm and this 500 ohm. So we moved from y and reached towards x, okay. We moved from y and reached towards x. This point y has the 500 ohm resistance and 300 ohm resistance, 500, 300. Here also the 500 and this 300 have their bottom ends connected at this common point here. This 300 ohm resistance, okay, this 300 ohm resistance, which means this, has its other end connected to 500 ohm, 300 connected to 500. This 500, okay, this 500 has its left end connected to this common point x, to which the left end of 300 ohm is also connected. So you see here, this 500 and 300, they are connected to x. So this is the equivalent circuit diagram. So it can be further reduced by simply combining these two resistances, because this 300 ohm and 500 ohm are in series, this 500 ohm and 300 ohm are in series. So this total resistance will simply be the addition of the two resistors. Okay, we will add the resistance, which will be 800 ohm, and here also the total resistance will be 800 ohm. Now these two 800 ohm resistances are now in parallel with respect to each other, because they have their top ends connected at one common point and the bottom ends connected at one common point. So the total equivalent resistance across xy will be 800 into 800 by 800 plus 800. Okay, so it will be 800 into 800 by 1600. This will be 400 ohms. The equivalent resistance will be 400 ohms. Okay, so here we have taken 4 questions on equivalent resistance, the circuits related to equivalent resistance. So we have covered different types of questions, the different types of approaches we have used. First we took the complicated circuit, the first, and I mentioned that we have to break it down into different parts and then analyze it separately. The other two questions, we moved from one side to the other, from right to left, and then we kept on calculating the equivalent resistance until we reached the end of the circuit. Here it is a slightly confusing circuit where it is connected in crisscross fashion. So you have to move from one end. Okay, why? We moved from one end and simplified the circuit as we reached up to x. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.